Last class, we started with schedule management knowledge area, and we finished with the first two processes. Plan, schedule management. We got the output as schedule. We know the output is schedule management plan. And then we discussed about define activities, which is the extension of create WBS. In create WBS process, we are decomposing the project, or we decomposed the project to various levels. What is the lowest level of WBS called? Type in the chat box or unmute and tell me. The lowest level of WBS is known as work packages. Correct, work packages. So define activities is the process of decomposing the work packages to one more level activities. So the output is activity list of all the activities. Then we discussed about sequence activities process. Almost done, only one slide left. Which we have to discuss about leads and lags. So sequence activities is a process of logically sequencing the activities, and you will use one of the four, logical relationship between the activities, such as finish to start, or start to start, or finish to finish, or start to finish. We discussed about that in the last class. Finish to start is the default relationship, as most of the activities will be in a project will be linked using finish to start. So in the exam, if they mention A and B are two activities, you should not assume any relationship between them. On the other hand, if they say A is the predecessor for B, then you should, even in case they don't mention the relationship, you should assume that as a finish to start relationship. So we discussed about finish to start. Finish of an activity drives the start of another activity. Start to start is start of an activity drives the start of another activity. Finish to finish means finish of an activity drives the finish of another activity. Start to finish is start of an activity will drive the finish of another activity. Check the last class video where we discussed with examples. So the only technique by which we are sequencing the activities is known as project schedule network diagram, precedence diagramming method, and the output is project schedule network diagram. So the only technique we are using to sequence the activities is precedence diagramming method. You have to know that for the exam. Sometimes there will be a confusion between sequencing and scheduling. Sequencing is just identifying the logical relationship between the activities, right? Activities will be shown by a box, and the arrow mark will show the the logical relationship. The only technique is precedence diagramming method, and others are supporting techniques. So what do you mean by lead and lag? Let's start with lag. So say we have two activities. Let's say one is concreting, another one is block work. Those who are in construction project, what is the logical relationship between concreting and block work? So is it finish to start, or start to start, or finish to finish, or start to finish? Usually the relationship between concreting and block work will be finish to start, right? This is start of the activity. This is finish of the activity. Concreting, this is start and finish of block work. So finish of concreting will drive the start of block work. For example, assume concreting will finish on day 10. Can you go and start block work on day 11? The answer is no. There is a waiting time, curing period. So assume you have to wait for 7 days before you start with the next activity. So whatever, even you are not in construction, let's say this is activity A, this is activity B. So after the relationship is finished to start, but as soon as you finish with activity A, you can't start with activity B. You have to wait for 7 days to start with activity B. This waiting time is known as lag in project management. So lag is the waiting time between the activities. Lag is the waiting time between activities. By the way, here you are seeing a finish to start relationship with lag. Lag can be with other relationships as well. For example, if by the way these numbers are indicative, it could be 7 days, 5 days, 10 days, 12 days, depends on the relationship. If you are saying 2 days after the start of A, you can start with B. What is the relationship between A and B? Start to start. But there is a waiting period of 2 days. So it's a start to start with a lag of 2 days. Start to start with a lag of 2 days. This is finish to start with a lag. This is start to start with a lag. Similarly, finish to finish. If I'm saying activity B can finish, let's say 1 day after the finish of A, what will be the relationship between, A and B? Finish to finish, but there's a lag of 1 day. So lag will delay the successor activity. In the last class, when we discussed, we have 4 activities, A, B, C, D, right? A will take 10 days, B will take 5 days, T will take whatever it is. So what is the duration of this? Let's say D will take 15 days. So some of you mentioned like it could be 15 to 40. But after finishing an activity, there can be a lag. Waiting time is known as lag. So the duration of the project can be even more than 40 days. That's about lag. Next one is lead. Lead is opposite to lag. Lead is opposite to lag. So what is lag? After finishing or starting an activity, you have to wait for some time to start or finish another activity. If I'm saying before 2 days of finish of A, you can start with activity B. Here also the relationship is finish to start, but I am accelerating the start of B by 2 days from the finish of A. If I know that I will be finishing activity A on day 10, I'll go and start activity B on day 8. These 2 days acceleration is known as lead in project management. So the waiting period between the activities is lag. The acceleration period between the activities is lead. Same like lag, you can have lead with other relationships as well. If I'm saying, okay, 5 days before the start of A, I can start with B. Relationship between A and B is start to start, but there's a lead of 5 days. Before 2 days of finish of A, I can finish with B. So here the relationship is finish to finish, but there is a lead of 2 days. So basically lag will delay the successor activity and lead will accelerate the successor activity. Only for understanding purpose, when there is a lag, I put a gap between the 2 activities. When there is a lead, I overlapped the activities. But when it comes to the examination, from the graphical presentation, you may not know is there a lead or lag. So they may say this is activity A, this is activity B, and this is start of A, finish of A, start and finish of B, and there is an arrow mark shown like this. So what does that tell you? Right? There is a finish to start relationship between A and B. Finish of A is driving the start of B. So A is the predecessor, driver is the predecessor, driven activity is the successor. So they haven't mentioned anything here. They haven't mentioned means it is by default finish to start. Sometimes they will say in the arrow mark, let's say Fs plus 5. How you should take this? F plus 5s. Finish the first activity plus 5. Wait for 5 days and then start with the next activity. This is a lag. So positive values with the relationship is a lag. Sometimes they will say Fs minus 5, same way F minus 5s. Finish the first activity, but before 5 days, you can start the next activity. So that is lead. So negative value with the relationship is a lead. Positive value with the relationship is a lag. That's what you have to know for the examination regarding lead and lag. Let's take another example to understand the impact of lag and lead on the project schedule. A and B with finish to start relationship. So no numpage with the relationship. So there is no lag or no lead. So I'll do A in 4 days, then B in another 3 days. 4 plus 3 in 7 days, I will finish both A and B. Next, we are seeing two activities A and B with the same duration, but the relationship is Fs plus 3. What is plus 3? There is a lag, meaning finish A in 4 days, 5, 6, 7 is waiting time, then start B on day 8, duration is 3 days, so 8, 9, 10, in 10 days you will finish A and B. Next, Fs minus 2, negative value is lead, so finish A in 4 days, but before 2 days, you can start with activity B. So on day 3, you will start with B, so A and B will finish in 5 days. So what you're also understanding from that graphical presentation is, if there is a lead or lag, that only impacts the successor. There is no impact on the predecessor. You will see in all 3 scenarios, activity A happens for the first 4 days. There is no change. There is no impact. Hope it's clear, right? So that's a lead and lag concept you have to know for the exam. We'll apply the lead and lag in the scheduling as well. So next, we are going to discuss about estimate activity duration. So in the last class, we discussed A will take 10 days to finish, B will take 5 days to finish, C will take 15 days, D will take 10 days. Now, I asked a question, what is the duration of the project? The answer is, we can't determine. So estimate activity duration is only about estimating the duration of the activities, not the duration of the project. Obviously, this information is required to estimate the duration of the project, but that will be done in the next process, develop schedule, one of the important processes for the PMP examination. So one of the points you have to know for the exam is the unit you will use for activities duration. Sometimes you will estimate the activity in or duration of the activity in number of hours. You'll say A will take, let's say, 10 hours to finish. Or you may estimate in number of days, or in number of weeks, or even in number of months, or even quarters. Major projects and all, they do it in quarters. So one of the first decisions to make when you are estimating the duration of the activities is about the unit. What unit we are going to use for activities estimation, sorry, duration estimation. By the way, this decision is already done. It is included in a document. Type in the chat box, what is the name of the document from which you will know, assume you are a team member now, you are going to estimate the duration of the activities, you have to know what unit I have to use, because that's important. Are you going to estimate number of hours, days, weeks, etc.? Which document will tell you the unit you have to use for activities, or in what unit you have to estimate activities duration? Type in the chat box or unmute and tell me. This is the methodology for a schedule management process. So in which document you will have the methodology, the guidelines? Very good. The answer is schedule management plan. So we discussed the output from plan schedule management is schedule management plan that gives the methodology for all the schedule management processes. So the guidelines about what unit to use for activities duration estimation will be in schedule management plan. Now the next question is, in another point for the exam, on what basis an activity or the unit is determined? Are you going to use number of hours, days, weeks, months, or quarters? It's based on what factor? The answer is the duration of the project. If the overall project duration is 2 to 3 months, a small project, then you will use usually number of hours. So 2 months project, let's estimate the activity in hours, or less than 2 months, 2, 3 months. If the duration of the project is like 1 to 2 years, okay, so 1 to 2 years, usually will go for days. More than that, it will be weeks or months. But most of the projects, they estimate the duration in number of days. Again, these are the points you have to know for the exam. And there are some factors you have to consider while estimating the activity durations. Sometimes the information what you see in this slide and next slide could be a direct question in the exam, like match the following kind of question. They'll say duration estimate, elapsed duration, effort on one side, the description will be the other side, and you have to match it. Few questions will be direct questions. Usually this will be one of the direct questions. So what is activity duration estimate? If I'm saying activity A will take, let's say, 10 days to finish, what this number stands for? 10 stands for the duration. We're talking about activity duration estimate, number of working days. So A will take 10 working days to finish. Next, elapsed duration. Elapsed duration is in calendar days, how long it will take to finish that activity. In calendar days, how long it will take to finish that activity. Let's say you are working for 5 days a week, and this activity is scheduled to start on a Sunday. You're working for 5 days a week, and you're scheduling this activity to start on a Sunday. These are a couple of assumptions. Okay, so Sunday to Thursday, Sunday to Thursday. So it's 10 working days. So 5 working days in this week, 5 working days in the next week, and in between you have 2 days weekend. So the elapsed duration of activity A is 10 plus 2, 12 days. So elapsed duration is the actual calendar time required for an activity from start to finish. Whereas duration estimate is the number of working days or working time, days or weeks or months, etc. When you are developing a schedule for a real-time project using a project management software like Primavera or Microsoft Planner, you don't want to worry about the elapsed duration. At the beginning, you define a calendar. What are the weekends, non-working times, and then you will provide only the duration, 10 days. As per the calendar you have configured, the software itself will go and choose 10 working days, excluding the weekends or non-working days. So concept is important, but in a real-time project, it is automatically taken care by the software. Question. Assume there was a break, holiday on week 1, right? So there was 1 day holiday in week 1. Type in the chat box. If the duration of activity A is 10 days, what will be the elapsed duration of activity A? In calendar days, how long it will take to finish activity A? So in the first week, you are not working for 5 days, you're only working for 4 days. It's a day off. And the duration of the activity is still the same, 10 days. So how long it will take to finish, or what is the elapsed duration of activity A? So we have 2 answers, 13 and 15. Okay, let's say this break is on Wednesday, or let's say Tuesday, for keeping it balanced. Whatever day, it doesn't matter. For a discussion, let's say it is Tuesday. So you will work for Sunday and Monday, 2 days, 1 day break, then Tuesday's break, Wednesday, Thursday, 2 days. Then you'll go for a 2 days break. Then next week you'll work for 5 days. How many days work is done? 5 plus 2, 7 plus 2, 9. 1 more day work is left. But there is a weekend, so you'll go for weekend for 2 days. You will come back the following week and you will finish the work in 1 day in the 3rd week. So the 2 plus 2 plus 5 plus 1, 10 days. But the non-working time is 1 plus 2 plus 2, 5. So 10 plus 5, as Shang mentioned, 15 days. So without a break, 12 days elapsed duration. With 1 day break, the elapsed duration goes to 15 days. Anyway, just for your information. Is it clear? Question. What is the duration of our training in number of hours? Let's see how many of you have gone through the schedule. What is the duration of our training in number of hours? 45 hours. Okay, great. Now, what is the elapsed duration of our training in number of weeks? What is the elapsed duration of our training in number of weeks? 5 weeks. So this training is happening over 5 weeks, but that doesn't mean all 5 weeks, all working days or all days in that 5 weeks we are doing the training. In 5 weeks, we are doing the training only for 45 hours. That's the difference between duration and elapsed duration. I think it's clear. Effort, the next concept, that's mainly about the human effort. How many man hours of work is happening in that activity, or man days of work is happening in that activity. Again, the effort can be estimated in man hours, man days, man weeks, depends. So the number of labor units or man hours or man days required to complete an activity. It will be also in man hours, man days, or man weeks. Let's take an example to understand the effort. Painting a building may take 80 hours to complete with 2 workers assigned to the job. Type in the chat box. From that statement, what is the duration of this activity in number of hours? No need to convert into days and all. In number of hours, what is the duration of the painting activity? 800? I think we added one more zero. Okay. 40, 80, 160. We have 3 answers. 80, 40, 60. Obviously, one of them is the right answer. So it says, painting a building may take 80 hours to complete. The information given after that is not relevant or not required. It says, our training is for 5 weeks. So duration is 5 weeks. Elapsed duration is 5 weeks. Painting will take 80 hours to complete. Duration is 80 hours. Yep, simple. The second part is not required to answer this question. Extraneous information to understand what is the duration of the activity. It's given there directly. Painting will take 80 hours to complete. So duration is 80 hours. Now the next information with 2 workers assigned to the job is required for the effort, to calculate the effort. So the question is, how many man hours of effort is put in that work to complete the activity in 80 hours? How many man hours of work is happening in that activity? That is about 80, 160. How many man hours of work is happening? That is the effort. So here, painting activity is happening for 80 hours. How many of them are working? 2 workers are assigned to do the work, meaning both the team members are doing the work for 80 hours. Each one, they are spending 80 hours in that work. So 160 man hours of work is happening. 160 man hours of work is happening. That is the effort we are putting, right? So our class is for 3 hours. So duration of our class is 3 hours for today. As of now, we are having 16 participants. But how many man hours we are spending? Each one of us, we are spending 3 hours. So it will be 16 multiplied by 3. So 48 hours we are spending. 48 man hours we are spending here. Man hours is effort. So from this first statement, we understood the duration of the activity is 80 hours. The effort required is 160 man hours. Add 2 more workers. Now the work will take only 40 hours. Type in the chat box. After adding 2 more workers, what is the duration of the activity now? After adding 2 more workers, what is the duration of the activity now? From the second statement. Okay, 80, 40, again changes, 40. So after adding 2 more workers, what about others? Today, first day of the week, right? Right? Those who are in Qatar, UAE, Saudi, first day of the week. You have to be energetic. Type in the chat box. So what is the duration of the activity? We have, okay, 80, 40, 40, 80. Again, the duration is directly given in the second sentence. It says, after adding 2 more workers, now the work will take only 40 hours. So duration of painting activity is now 40 hours. How 80? I'm talking about second statement now. Okay, now question. After adding 2 more workers, reducing the duration of the activity to 40 hours, what is the effort required now in man hours? How many man hours of work is happening in the second statement, the second stage? Is it still confused? I thought it's a simple concept. How many man hours of work is happening? Man hours. Effort. So now the work is happening for 40 hours, right? Multiplied by how many of them are working? 4 of them are working. Like already you have 2, you're adding 2 more. So 4, 160, still same. In the first sentence and the second sentence, the effort what you're putting is same, but the difference is number of people working in the activity. Here we are having 2 people working in that activity. Here we are having 4 people working in that activity. So is this true for all the work, all the activities of a project? Like in any activity, if I double the resource, the duration will be reduced to half. Type in the chat box A, yes, B, not necessary to be. What do you think? In all the activities of a project or in any activity of the project, if you double the resource, duration will be reduced to half. The answer is B, not necessary. In some cases, yes, possible, like building, painting. Some of them can paint inside the building. Some others can do from outside the building. So you have a lot of work area, they can do it. But not in all the activities. Sometimes you have to work in restricted zones, work friends will be less, etc. If 10 people can finish the activity in 20 days, 15 people may finish in, let's say, 17 days. 25 people may never do it. You have to know that. Sometimes adding resources may increase the duration of the activity. Simple way to understand, if 3 or 4 people are sitting together to make a decision, or 10 people or more than 10 people are sitting together to make a decision, where decision will be made faster? When there are less number of people. Similarly, when it comes to the project, sometimes when you add more resources, it may increase the duration. You need to have more planning, more coordination, issues, etc. That may increase the duration. So by adding or keep on adding the resources, you cannot bring the duration to 0. You can't. So it is not possible in all the cases. Like I'm asking to my electrical engineer, how many man hours of electrical work you have to do for this room? He says 50 man hours of work, let's say. I can't tell him, okay, that's good. Bring 50 electrical engineers and finish the work in 1 hour and hand over to me. That's not practical. So in project management, there is nothing called resource maximization. It's all about resource optimization. To understand about resource optimization, this could be an exam question as well. For the examination purpose, you have to know about law of diminishing returns. X-axis is team size, Y-axis is productivity. There is a calculation, but you don't want to know the calculation for the PMP exam. Just the concept is enough. So as you can see, as you are increasing the team size, you are getting equivalent productivity improvement. Let's say you are adding 1 person and you're getting productivity, additional productivity of 1 more person. That is up to this particular point, right? Increasing returns. But after this point, if you add 1 person, you will get the productivity of 0.7%. So that is decreasing returns. You are not getting the best result. Now, that also will be, again, as you increase the productivity, this is cumulative productivity, by the way. So that's why it is shown like this. And that also it will go to 0.7, 0.6, 0.5, it will reduce. So team size is increasing, but productivity you may not get the equivalent productivity. But after a certain point, if you still keep on adding the resources, if you're adding 1 person, you may lose 2 persons productivity, that is negative returns. By the way, according to the project you are in, you can calculate these points. That's not required for the PMP examination. So when you say optimum resourcing, a project manager will usually assign resources to that point, right? After that, you will be starting to get decreasing returns. You have to spend more, but you get less productivity. But in some cases, project manager may go a little bit beyond knowing that we are getting negative returns, but we have to do additional work. We have to finish early. So we still keep adding resources to a certain extent, but never you will cross this point, because if you cross that point, it's just waste of money. You are not getting any equivalent productivity improvement. In fact, it is reducing the improvement. That's about law of diminishing return. Another concept you have to know for the examination is student syndrome. We are talking about the factors to consider when you are estimating the duration. Student syndrome, I think already I mentioned about this in one of the initial classes, keeping the work to the last minute, right? During college days, most of us, as we discussed earlier, we studied towards the end of the semester, maybe 1 or 2 days before the exam. That is student syndrome. As I mentioned earlier, don't think that that's only happening during college time. Even at work, it happens. So they gave 5 days. They assigned the work to me at this particular point, and they gave me 5 days to finish the work. I know I can finish the work in 3 days. So the first 2 days, I'll be working on something else. That's a mindset. This report I can do in 2 days. This work I can do in 2 days or 3 days. So let me go and attend a meeting. Let me do that and this. Then suddenly towards the end, oh, I have only 2 days left or 3 days left. I'll start doing the work. You can see the productivity or the effort I'm putting. Then obviously, because I'm doing in the last minute, sometimes there will be delays, sometimes there will be quality issues and so on. What is ideal? You are doing like this. Okay, you start slowly, go to the peak productivity, then towards the end when you complete, you close it. But this is student syndrome, keeping the work for the last minute. Parkinson's law. This is other way around. According to Parkinson's law, the work expands as per the time availability. So again, here is another activity got assigned on this date, and they told me to finish in 10 days. Immediately I started working on that with high productivity. When I reached here, I know I will be finishing this work in, let's say, 5 days, 50% of the duration. I'll see, oh, we have a few more days left. And if I continue in this pace, I'll finish in 5 days. So automatically the productivity will reduce and the work will finish only in 10 days. So even you are giving more days, it may not be beneficial. There are many reasons why that is happening. One, it's a mindset for both student syndrome and Parkinson's. We have time, we can do it. Two, if I finish this work in 5 days this time, next time when they assign a similar work to me, they will assign or they'll give me only 5 days. What if I won't be able to finish in 5 days? If there is a delay, there will be questions. To be in a safer side, let me finish in 10 days. Why I have to reduce to 5 days? This is another reason why Parkinson's law happens. So these are some of the factors you have to consider when you are estimating, the duration of the activities. You should know the difference between activity duration estimate, elapsed duration, effort, and the details about student syndrome, Parkinson's law, and diminishing returns. Question. Assume you are a project manager representing a contractor or a consultant in that project. You just won a contract from a client. The duration mentioned in the contract is 300 days. The duration mentioned in the contract is 300 days. Type in the chat box. Is it A, like activity duration estimate, or working days, or B, elapsed days? So just leave activity duration estimate. So that 300 days mentioned in the contract, is it working days? Then type A. Or is it elapsed time? Type B. B, elapsed time, B. The answer is, if you're not working for 7 days a week, that's an elapsed time. That's not 300 working days, right? So that is a calendar time from this date to this date. If you're working for 7 days a week, yes, that is the duration as well. But if you're working for 6 days a week or 5 days a week, you need to go and find in that 300 days, excluding weekends, holidays, and etc., how many working days I'm having to finish that particular project. So it's not A, it's B, that is elapsed duration for that particular contract. It includes weekends, holidays as well. Right. With that, let's talk in detail about, the estimation techniques. You have to know there are 3 estimating processes in PMPOG guide. If I go back to the process mapping, estimate activity duration in schedule management, estimate cost in cost management, estimate activity resources in resource management. For all these 3 estimation processes, the tools and techniques are the same. So I'm going to explain about these estimating tools and techniques in estimate activity duration process. Later in estimate cost and estimate activity resources, I'll ask you to refer back to this particular video for you to understand or recall the concept. So what are the techniques we are having in estimating the duration, resources, and cost of the activities? Analogous estimation, parametric estimation, 3-point estimation, bottom-up estimation, and reserve time. We'll talk about reserve time in a minute. Before that, let's start with analogous estimation. You have just started to discuss about a project and assume this project is just approved. You are in a very early stage of the project. You haven't done the planning yet. All these are for predictive projects, by the way. Now, one of the stakeholders is asking you, okay, we have decided to go ahead with this project. What will be the duration of this project? Again, the stakeholder is not looking for a very accurate number. They are looking for a ballpark figure to get an idea approximately how long it will take. Since I'm in a very early stage of the project, I don't have enough information from the current project to do the estimation. But I know earlier in my organization, they have done a similar project in the past. So what I'll do, I'll go and refer to that project details and I'll see how long that project took to finish, and based on that information, I'll be estimating the duration of the current project. Okay, last time we finished in 200 days. Yeah, now the scope is a bit different, looks more than what we did in the past. So I'll say 250 days, but that's a rough estimate. This is analogous estimation. I told you about duration of a project. You can use it to estimate the duration of an activity. You can use it like same thing. Okay, how much it will cost? I want a ballpark figure. Same thing. Go and check the cost of a similar previous project. Based on that, you estimate the cost of the project. Resources, same thing. So analogy means comparison. Analogy means comparison. So you are using historical data from a similar activity or project to estimate duration or cost or resources, also known as top-down estimating. By the way, this technique can be used in estimating the duration of an activity as well. I have an activity to do. I'll compare with the previous project, how long a similar activity took to finish, and I will estimate based on that. Why I'm going for analogous estimation? That's the point. They will not ask you what is analogous estimation. They will give you a scenario and they will ask you what is the best technique to use for estimation at this stage. So if you are seeing this talks about an early stage of the project, we don't have enough information on the current project, then we will use analogous estimation. So analogy means similarity. So use historical data from similar project or activity for estimation, known as top-down estimation. Less costly and time-consuming is an advantage. Okay, I have to refer to the historical data. I'll get it from my PMO and we do the estimation. Used when project information is limited. In the early stage, you will have limited information. Maybe inaccurate depending on quality of historical information. Your analogy should be made with a similar project. Let's say I got a project in which I have to set up an IT lab in a school. Now I'm seeing in the past, we have set up an IT lab in an IT organization. We have that information. Question: can I use the analogy of setting up the IT lab in IT organization to set up an IT lab in a school? Type A, yes. Type B, no. What do you think? B. Okay, the right answer is also B, because there is no analogy. These are two different, even though it's IT lab, but the way how you will set up for IT company or a construction company, for example, or in a school may not be the same. So there, you are basing it on a wrong analogy, so it can be inaccurate. Next, parametric estimation. What is this? We are going to cut the project into equal pieces, and we're going to take one piece at a time. Just a minute. So as I told you, we are cutting the project into equal pieces. We are taking one piece at a time, and we are estimating for that piece. Based on that, we are estimating for the whole activity or for project. So that piece is the parameter. Let's take an example. Assume, let's go for cost, then we'll talk about duration. The area of construction is 1000 meters square, and I want to calculate how much it will cost me to finish that particular work or activity, let's say project. So I'll take a parameter. My parameter is going to be 1 meter square, and I'll see or estimate how long it will or how much it will cost. Let's say 1 meter square will cost 200 reals. That means 1000 meter square will cost 200 into 1000, 2 million reals. This is parametric estimation. What is my parameter? 1 meter square. Let's say in an activity, I have to complete 25 deliverables for the duration, right? 25 deliverables. I want to calculate how long it will take to finish. I'll take one deliverable as my parameter, and I'll calculate, okay, one deliverable will take 4 hours to finish. That means 25 deliverables, 4 into 25, 100 hours to finish. This is parametric estimation for duration. But there is a rule. The parameter what you are choosing should be scalable and linear. Meaning, first meter square will cost me 200 reals. Second meter square will cost me 500 reals. Third meter square will cost me 50 reals. This is not linear and scalable, and you cannot use this. Say, first drawing will take 4 hours, or deliverable will take 4 hours. Second deliverable will take 24 hours. Third deliverable can be done in 0.5 hours. You can't use this. So it should be more or less the same duration or cost of your parameter, right? So that is also a drawback. Uniform units of work are not typical in projects. It's not that common that, the work will be uniform. Every meter will cost this. Every deliverable will take that much of time, etc. Okay. Advantage: can produce higher levels of accuracy depending on sophistication of data from the model. If the duration of your parameter is accurate, the whole estimation will be accurate. Now the drawback is, already we discussed, having a linear scalable data or work is not that feasible always. Next one is, does not account for learning curve. What is this learning curve? Let's go to this example. First deliverable, while I'm doing it, I'm also learning, right, how to do it correct. So there could be some mistakes, some reworks. So it will take more time to complete that deliverable, and it will cost me more. But when I repeat it, already I learned by doing it, so it will take less time. It will cost me less. There will be less errors, less defects. So if I do it for if I do it for, let's say, if I do it for 10 deliverables, 12 deliverables, comparing to the first deliverables time and cost, 12th deliverable will take less time and it will cost us less. because of the learning curve. And that is not taken into account. In fact, the modern parametric estimations, they consider learning curve as well, but for the PMP exam, traditional method, they don't consider learning curve. Okay. We'll skip 3-point method. We'll talk about that later. Now we'll talk about bottom-up technique. What is this bottom-up technique? To understand about bottom-up technique, you have to go to WBS, to the lowest level of WBS, which is work package, which are the work packages. Then one further level, right? That is your activities. You will go to individual activities. You will do the estimation, activity A, how much it will cost, B, C, etc. And then you will roll up to the work package level, then roll up to the components, deliverable, to the project level to get the overall, cost of the project. That is bottom-up estimation. You have to know for the exam, comparing to all these techniques, most accurate estimation you will get from bottom-up estimation. Comparing to other techniques, most accurate estimate you will get from bottom-up estimation, because you are going to the activity level, you are considering the constraints there, you are looking into assumptions and so on, and you are calculating at the activity level, which you are rolling up to the higher levels. The drawback is time consumption. How many activities you can have in a project? Tens, hundreds, thousands. Assume you are having 1,000 activities. Then what you are doing for one activity, repeat for every activity is various data. So it is time consuming, right? So maybe very time consuming. And in an early stage of the project, when you don't have enough project information, you cannot use this technique. You have to wait until you get your complete WBS, then activities, the details, then only you can perform bottom-up estimation. Early in the project, you will go for analogous estimation. So very accurate, that's the advantage, and gives lower level managers more responsibility. That is actually comparing to analogous. Analogous, you are getting like one big number for the whole project. If I am in level 3, level 4, what is my share or my project or my parts share? There will be always debate with others because you have a high level estimate. But in bottom up, every level you have the estimate. So if I'm whatever level I'm in, higher or lower, I know what is the timeline for me, what is the budget for me, etc. That's about bottom-up estimation. Before going to 3-point estimation, let's talk about reserve time. Anywhere they say reserve, which is also known as buffer, contingency, that relates to, the risk involved in the activities. Let's take an example to understand reserve time. Let's take an example to understand reserve time. So let's say I have to complete 10,000 meters of cable laying. And I'm using parametric estimation to calculate the duration. My parameter will be 100 meters. Let's say 100 meters, my team will be able to finish in 3 hours. So if 100 meters can be done in 3 hours, 10,000 meters will be done in 300 hours. That is parametric estimation. However, in some locations, when they are digging to lay the cable, there could be some obstacles. They have to remove those obstacles and then lay the cable. It can take more than 3 hours for that 100-meter stretch. So if I put exactly 300 hours, when the team is hitting with an obstacle, there will be panic. Oh, we have to remove the obstacles, then lay the cable. We only have time to lay the cable. This is going to delay our work. That will impact our commitment, our bonus, etc. So to avoid this, what we will do, in addition to the calculated cost or time, it is applicable for both, we will add an extra time or cost to account the risk involved in the activities. That extra time or cost, what you are adding, is known as reserve time, buffer time, or reserve cost, buffer cost, contingency time. Let's say they are taking a decision across the board at 10% as a reserve time. That means 10% of 300 is 30. So laying 10,000 meters of cable will take 330 hours, where 30 is for risk, or 30 is reserve time or risk time. So when the team is hitting up with an obstacle, they know nothing to panic. We have a reserve time. We will take from there, like it will take 3 more hours or 4 more hours to complete. We have 30 hours as reserve time. From that, we'll take 4 hours and we'll remove the obstacle. That is about, reserve time. Same thing for cost. You will have a contingency cost as well. Now, the last technique we are having, is actually 3-point estimation. 3-point estimation is used in some industries, but that is one of the important techniques for the PMP exam. Hardly you will get around 5 questions based on calculation. And sometimes one among that is based on 3-point estimate. So if someone is asking you how long it will take for you to drive from your home to office, you can't say exactly 27 minutes, 30 seconds. You can't say that. There will be fluctuations, a lot of variables included. Sometimes there will be less traffic, sometimes more traffic. Sometimes, I have to stay longer in some signals. Sometimes all signals will be open because of the integrated transport system, what they are using. There are a lot of variables in estimating the duration for that question, how long it will take to reach your office from your home. So that's where you'll go for 3-point estimation, right? So we will estimate the duration of the activity or cost of the activity using 3 estimates. First one is pessimistic estimate. I'll take it as P. Next one is M, most likely estimate. Next one is O, optimistic estimate. So it is PMO, Project Management Office. Here it is pessimistic, most likely, optimistic. If everything goes wrong, maximum how long it will take to finish an activity is pessimistic time, or how much it will cost is pessimistic cost. This is in fact worst case scenario. Pessimistic is worst case scenario. On the other hand, if everything goes perfectly according to our plan, minimum how long it will take to finish that activity is optimistic time. It's optimistic time, which is best case scenario. From the past experience and knowledge, normally how long it will take to finish an activity is most likely estimate time, or how much it will cost normally is, most likely cost. That is normal scenario. Always it won't be best case or worst case. It will be something in between. It won't be those extremes. So let's go back to our question. How long it will take you to reach your office from your home? Instead of giving an answer immediately, I'm going to do this observation for 10 days. Let's say 1, 2, 10. Day 1, I took 27 minutes to reach office. Day 2, 30 minutes. Day 3, 25 minutes. Day 4, 45 minutes. Day 5, 30 minutes. Day 6, let's say 28 minutes. Day 7, 30 minutes. Day 8, let's say 35 minutes. Day 9, 30 minutes. Day 10, let's say 40 minutes. For example. Now, what is the pessimistic time? Maximum, how long it took for you to reach the office in that 10 days observation. Type in the chat box. From the given data table, the pessimistic time is 45 days. So it will take maximum 45 hours to reach the office. 45 minutes. 40 minutes to reach the office. Now, what is optimistic time? Minimum, how much time it took to, reach office. From this observation, what is the optimistic duration? 25 minutes. On day 3, it took 25 minutes for me to reach the office. So that is optimistic. That's not most likely, optimistic. Now, Most of the days, how long it took for me to reach the office? That is most likely or normal duration, normal scenario. Most of the days, how long I took to reach the office from this observation? So, what is the most likely duration? Day 2, I took 30 minutes. Day 5, 30 minutes. Day 7, 30 minutes. Day 9, 30 minutes. So 4 out of 10 days, I reached in 30 minutes. So the most likely time is 30 minutes. Most likely I'll be reaching the office in 30 minutes. That's a normal scenario, right? So now, based on these 3 time estimates, pessimistic, most likely, and optimistic, we are going to calculate time or cost estimate, the expected value. Expected value is P plus M plus O divided by 3. This is based on something called triangular distribution. You don't want to know about the distributions in detail. Just understand using triangular distribution, you will take a simple average of these 3 time periods or cost to calculate the expected value. On the other hand, we have also beta distribution. As per beta distribution, expected duration or expected cost is pessimistic plus 4 times most likely plus optimistic divided by 6. Optimistic divided by 6. This is weighted average. So most likely time is having higher weightage. That's it. So for the PMP exam, if they give only PMO values and they are not specifying what distribution to use, you will use triangular distribution by default, it's simple average. If on the other hand they say beta distribution or weighted average, then you will go for beta distribution formula. Then you will go for beta distribution formula. In beta distribution, there are a few more formulas you have to know. Second one is standard deviation sigma. It is P minus O divided by 6. Third one is variance. It is sigma square. There may not be questions in the exam about standard deviation and variance. Just know that this is syllabus we are discussing, but nobody told they got a question, based on standard deviation and variance. So variance, we don't have a separate formula. Calculate the standard deviation and the square of that. That is about the 3 form. Expected value, beta distribution, weighted average, standard deviation, and variance. Now, when you are using the data, sometimes they'll give the data and ask you to interpret. You have to be careful. Outliers should not be considered. What do you mean by outlier? In an average, it took between 25 minutes to 40 minutes to reach my office. But one day, it took 4 hours for me to reach the office. One day it took 4 hours. Usually it takes between 25 to 40 minutes. This 4 hours is outlier. You should not take that as a pessimistic duration. Why? Something might have happened on that day, some accidents or breakdown, road closure, whatever it is. So you should not consider that as a pessimist. So that is part of data analysis. We discussed earlier. When you're analyzing the data, you see there's an outlier. Don't use outliers. Ignore outliers. Okay? That's about the 3-point estimates. So if I go back to the slides, this is triangular distribution, only expected value formula. Beta distribution, we have expected value with weighted average. We have, standard deviation, P minus O by 6. Weighted, by the way, beta distribution is also known as PERT, Program Evaluation Review Technique. Beta distribution is also known as PERT, Program Evaluation Review Technique. That's about the, estimation techniques, right? Analysis estimation, parametric estimation, 3-point estimation, bottom-up estimation, reserve time or reserve cost. With that, we are moving on to the next process, one of the important processes, develop schedule. how to develop schedule for a predictive project. There are many techniques by which you can develop schedule for a predictive project, but for the examination purpose, we are only going to discuss about critical path method, CPM, critical path method. What is a critical path? The definition is here, the sequence of activities that represents the longest path through a project which determines the shortest possible duration. So, critical path is the path that determines the duration of the project. Okay, longest path and shortest possible duration. Let's take an example. I have a sequence here. I have put the duration also. Now I have to go and check how long this project from start to end will take to finish. Right? Activity A, 6 weeks. 2, 4 and 3, 5 are in parallel. Then after finishing 4 and 5, you can go for activity 6. So how long this will take to finish? So in 6 weeks, they will finish with activity 1. Then I can start 2 and 3 at the same time, but we'll follow the path 2 and 4. So I'm following this path. In another 4 weeks, I'll finish with activity 2. So 6 plus 4. In 10 weeks, I'll finish with 1 and 2. Then another 3 weeks for activity 4. So 13 weeks. In 13 weeks, I'll finish with 1, 2, and 4. Can I go and start with activity 6? The answer is we don't know, because we don't know when activity 5 will finish. Only after knowing when activity 5 will finish, then we can make a decision when to do activity 6. So let's go to the other path. A, 6 weeks. 1 plus 3, 6 plus 5, 11 weeks. In 11 weeks, we'll finish 1 and 3. Then 4 weeks for activity 5. So 11 plus 5, 16 weeks for activity 5. 11 plus 4, 15 weeks. This is activity 5, 4 weeks. Question. When you will start with activity 6? A, on week 14, you will start with activity 6. Or B, on week 16, you will start with activity 6. When you can start with activity 6 according to this network diagram? Anybody can answer that? On week 14, you can start activity 6, or in week 16, you can start with activity 6. The right answer is, before going to the right answer, the concept is you have to finish with activity 4 and 5 to start with 6. 4 is finishing on 13th week. 5 is finishing on 15th week. When can I start with activity 6? Right? Like you have to finish the training, and also the application should have approved to take the PMP exam. So PMP exam you can take if you finish the training, an application is approved. Let's say this is happening in parallel, for example. Obviously, after the finishing the training, you have to submit the application. Let's assume. Now, we finished the training in 5 weeks, but an application is finished only in 7 weeks. When you can take the exam? After 7 weeks. So you have to finish with 4 and 5. So only after 15th week, you can start with activity 6, 1 week duration. So in 16 weeks, you will finish this project. So which path is determining the duration? Path 1 is activity 1, 2, 4, 6. The duration of the path is 14 weeks. Path 2, 1, 3, 5, 6. The duration of that path is 16 weeks. So critical path is a 1, 3, 5, 6, which determines the duration of the project. When you look into the project schedule in Primavera or Microsoft project, you will see some of the activities will have a red color bar. Those activities are in fact critical activities of a project. So minimum it will take 6 weeks to finish, 15 weeks, right? So 16 weeks to finish this particular project. You cannot finish this project in less than 16 weeks. That's the meaning of shortest possible duration. Longest path 1 is 14 weeks, path 2 is 16 weeks. So the longest path is a critical path. 16 weeks path is that is 1, 3, 5, 6. If you follow 1, 2, 4, 6, it will be only 14 weeks. So longest path and shortest possible duration usually will be the same. That's the idea behind critical path method. What we will do, we'll take an example and we'll use this example to discuss all the concepts you want to know for the exam. In fact, the calculation is not that important. In the past, there were questions based on the calculation, what you're going to discuss for the past few years, 3 or 4 years, no, but there is no question in the examination based on the calculation. So we'll go quickly with the calculation, but we'll focus on the concept. So here is a table of activities A to K, duration in days, and predecessors given here. So the relationship is not mentioned. What relationship you will assume? Finish to start. Finish to start. Okay. So first step is to create a network diagram. For that, we are going to use precedence diagramming method. A box will represent, the activity. Inside the box, I'll have the name of the activity and its duration. So here is the activity name, duration. A, B, and C, they don't have any predecessor. D, A is the predecessor. E and F, B is the predecessor. G and H, C is the predecessor. So we have here A, B, C, no predecessor. D, A is the predecessor. E and F, B, G and H, C. Further, I, D and E are the predecessors. J, F and G. So I, D and E are the predecessors. J, F and G. And for the last one, K, I have 3 predecessors. I, J and H. So we have created a network diagram using PDM, precedence diagramming method, where the box is shown as box represents activities and the arrow mark the relationship. By the way, if you are going to take the examination from the center, you will be given with a erasable board, small board, and a marker. If there is a question, rarely, but in some question you may want to write down and make a note of it to calculate or to find the right answer, you can use that erasable board and the marker. So you can draw like this and you can calculate. What if you are taking the examination from home, right? Sometimes some of you may want to take the examination from home, especially, you don't have an exam center nearby your town or town where you're living. Then in the online examination, you're taking the examination from home, you are not allowed to use any materials with you. Instead, if you want to draw, you have to use the whiteboard, which will be available in the exam screen itself. So you can understand and practice the whiteboard, what you will use in the examination before you go for the exam. If you go and search for Pearson VE whiteboard, no need even practice. Pearson VE is the exam partner of PMI whiteboard. You will get a first link here, ensure that it's from Pearson VE, and practice online whiteboard. You have the details of what is it, you can have a look into that. There are 2 areas. One is, writing area, another is drawing area. So you want to do some calculation, you have to store somewhere, then use it. So you can use it like, for example, 2 multiplied by 67 equal to, and then you put the number there, then you take another one and you store it here and you can find the answer. To draw, you have to go for the drawing area. This arrow is to open the, where is that? Drawing area. Okay. It's very simple. Rough hand sketch. You can create boxes and you can do the calculation. You can erase some part, or you can undo, redo, or you can delete everything. So this is writing area. This is drawing area. Very simple to use, but just practice. What are the tools available? You have a description, which I have already shown. So how I searched is Pearson VUE whiteboard. Pearson VE whiteboard, and you will get that. That is, even you want to use it for some other making a note of the numbers and do the calculation, you can use it if you are taking it from your home or office. So we are going to calculate few values. For example, early start, early finish, late start, late finish, total float, free float, project float, and all. So every activity, there will be 2 start dates and 2 end dates. Early start, late start, and early finish, late finish. Many of you may know about these concepts. What is early start, late finish, late finish? To bring everyone in the same page, I'll quickly explain what is early start, early finish, late start, late finish. So assume there is a seminar at 7 p.m. Registration starts at 6 p.m. and you have to drive for 2 hours to reach this location. Let's say. So as early as possible, when you can reach the location is 6 p.m. At 6, if you reach, you can go register, have a coffee, network with others. You can use your time effectively. If you're there at 5:30, then you have to wait for 30 minutes. So without wasting any of your time, as early as possible, when you can reach the location is 4 p.m. When you can reach the location is 6 p.m. If you want to reach there at 6 p.m., since you have to drive for 2 hours, you have to start at 4 from your place. So when you can start an activity is as early as possible. When you can start an activity is early start. When you can finish an activity is early finish. Now assume you can't start at 4, you have other commitments. Now, at the worst case, I have to be in seminar hall by 7. Assume the sessions are not getting recorded, for example. So if you are late by 30 minutes, you will miss half an hour program. So as late as possible, when you can reach the location is 7 p.m. If I want to be there at 7 p.m., I have to start from my place at 5 p.m. So as late as possible, when you can start is late start, when you can finish is late finish. Now assume this seminar will go for 3 hours and it will finish at 10 p.m. followed by a good dinner, but that's not the focus of our discussion. For a 3 hours seminar, you have a flexibility of an hour to work with, right? Between 4 and 5, anytime you can start, accordingly you'll reach the location. Between 4 and 5, anytime you can start and you'll reach the location. So this flexibility is known as float. This flexibility is known as float. We'll talk about total float, free float, etc. So as per the legend, the top left will be early start, top right will be early finish. Bottom left will be late start, bottom right will be late finish. And then in the bottom center will be total float. Free float is not that important. We'll just discuss about that. Right. Let's go back to this example we had earlier before we start with a new exercise or example where we'll discuss all the concept. Let's see what is the float here. If you look into the critical path activities, they will not have a float. So what is float is the flexibility what I have in the work. For example, A will finish in 6 weeks, A plus B 11 weeks, 1 plus 3, 11 weeks, 1 plus 3 plus 5, 15 weeks, this is 16 weeks. Here it will be 6 plus 4, 10 weeks, and 10 plus 3, 13 weeks. Critical path will not have any float. Critical path always will have 0 float. Non-critical path, here we have 2 activities in non-critical path, 2 and 4, they will have the float. Assume one of these activities, 2 or 4, got delayed by a week. This you couldn't finish in 10th week, you finished in 11th week. Here it went to 14th week. Is there any impact on the project duration? No. Still you will finish the project 16 weeks. Assume activity 2 got delayed for 1 more week. So this will finish in 12 weeks. 12 plus 3, it will finish in 15 weeks. If you see now, 5 will finish in 15 weeks and 4 also will finish in 15 weeks. So 2 weeks, you are able to delay 2 and 4, like 2 weeks. Now, in case you delay for 1 more week, like you finished this in 13th week, this goes to 16, and the project will end in 17th week. So that will impact the project. So without impacting the project, maximum how long you can delay an activity is total float, right? In this example, activity 2 and 4, non-critical path activity can delay for 2 weeks. Total float will be 2 weeks. Simple way to understand. So in the other example, what I gave you, total float is 2 hours. 2 hours. 1 hour. 4 to 5, 1 hour. So we created the network diagram. According to the legend, early start and early finish will be in the top left and top right. So let's go and do the calculation. Again, calculation is not that important. Concept is important. What is early start, early finish, how it is used in the scheduling. So questions will be based on that. As early as possible, when you can start with activity A, B, and C, because A, B, and C are not having any predecessors. They don't have any predecessors. If I'm going to start this project tomorrow, Sunday, A, B, and C can start on Sunday. So whenever I'm going to start, the start date of the project, I'm taking it as day 1. So what is the early start of A, B, and C? Day 1 of the project. A, B, and C. Whenever you are starting, tomorrow, next month, next week, whenever I'm starting, A, B, C can start. So early start is day 1. To calculate the early finish of all the activities, we have a formula. Early finish is equal to early start plus duration minus 1. Let's do this for activity A. Early finish is equal to early start 1, duration 3, minus 1. 4 minus 1 is 3. So early finish is, 3 weeks. Sorry, 3 days. Day 3, not 3 days, 3 days, day 3. So the concept is simple. Activity A will start on day 1. The duration is 3 days. Day 1, day 2, day 3. Day 3 evening, you will finish with activity A. Same way, if you go and calculate, type in the chat box or unmute and tell me what will be the early finish of activity B. Early finish of activity B will be, so it will be 1 plus 11, 12, 12 minus 1, 11. Not 10, it will be 11. What will be the early finish of activity C? Using the same formula, early start plus duration minus 1. We have the early start here, which is day 1, and duration is here 9. So 1 plus 9 is 10. 10 minus 1 is 9. Okay. So we have the early start and early finish of all the first set of activities. Moving forward in the network, this is actually the technique what we are using to calculate early start and early finish of the activities is called forward pass. Why it is called forward pass? We are starting the calculation with the first activity or activities, and we are moving forward in the network. So moving forward, what will be the early start of activity D? For that, except the first activities, for all the remaining activities, to calculate the early start, we have a formula. Next day of highest date value from its immediate predecessor. For D, predecessor is A, finishing on day 3. So next activity, that is activity D, can start on day 4 morning. So when you are finishing activity A, day 3 evening. So as early as possible, when you can start with D is day 4 morning. Type in the chat box, what will be the early start of E and F? E and F, they are having same predecessor, which is B. B is finishing on day 11. So when E and F can start? Okay. Yes, all of you are right. It is day 12. Early start of activity E and F is day 12. One more question, then we'll go with all the answers. What will be the early start of activity G and H? G and H will be day 10. It will be day 10, right? Okay. Now, to calculate the early finish, we'll use the same formula, early start plus duration minus 1. Type in the chat box, what will be the early finish of activity D? Early start is 4, duration is 7, so early finish will be 7 plus 4, 11, 11 minus 1, 10. So hope, okay, very good. All of you are typing the right answer. That means you know how to calculate the early finish of activity E, F, G, H. You can see there. For E, it will be 12 plus 9, 21 minus 120. Anybody having a question? How to calculate the early start and early finish of the activity so far? Moving forward. Next activity, activity I, is having two predecessors. D finishing on day 10, E finishing on day 20. Type in the chat box, What will be the early start of activity I? So we already discussed in the example, only after finishing with D and E, we can start with I. D is finishing on 10, E is finishing on day 20. The highest date value is 20, so the next day is 21. Very good. Now I want to see all your answers. What will be the early start of activity J? Okay. Very good. All of you are right. The highest is 16, so next day is 17. So activity H is finishing on day 28. What will be the early start of activity K? Okay, 29 is the wrong answer. Why? Maybe, but now it's the wrong answer. Why? Because activity K is having three predecessors, I, J and H. We don't know when J and I will be finishing, correct? Only after knowing that still 28 is highest and 29 is the right answer. So now first we have to go and calculate what is the early finish of I and J. Again, this is just to make you understand the concept. Now it's clear. Okay, already some of you are giving correct answers, but let's start with I. 21 plus 17 minus 1 is 37. That is the early finish of I. J, 17 plus 5 minus 1, 21. So now the highest is 37. As many of you already mentioned in the chat box, the next day is 38. So the early start of activity, yeah, correct. All of you got the concept. Where are we? Okay, 38. Early finish, same formula, 38 plus 3 minus 1, 40. So we calculated the early start and early finish of all the activities. Not only that, we also calculated the duration of the project. What will be the duration of this project? The duration of the project is 40 days. When I say duration, it's working days. We start, okay, no, starting with 0, like we took actually first day of the project as day 1. You can start with day 0, but my formulas are not applicable. My concept is also not applicable. So anyway, exam may not ask you a question based on calculation. This is for you to you understood now what is early start, early finish, and how it is used for calculating the project duration clearly without only going through theory, by going through an example, right? So if you are going to use day 0 as day 1, sorry, instead of day 1, there are some changes. So it's not important. So I'm not going to focus on that. Just leave it. Stick to day 0. The difference is simple, by the way. All plus 1 minus 1 will go, and A is finishing on day 3. D will also start on day 3. So just avoid the confusion. That's not important for the examination. Now, through forward pass, I have calculated the duration of the project. This project will take 40 working days. Now I want to know, or I'm going to calculate the late start and late finish of the activities. For this, I will use something called backward pass, meaning I will start my calculation with the last activity and I'll move backward in the network. The purpose of backward pass is to know within the duration of the project, what flexibility do we have. So how we considered day 1 as the first activity is early start. Similarly, the last day, that is day 40, last day of the project, will be the late finish itself. So early finish of the project will be the late finish for the last activity, 40. And moving backward in the network, we have the formula late start is equal to late finish minus duration plus 1. So it is 40 minus 3, 37, 37 plus 1, 38. 38. Now, moving backward the network, for all the remaining activities, to calculate the late finish, we have a formula. Previous day of lowest date value from its immediate successor. For I, J and H, we have only one successor, which is starting on day 38. So the late finish is day 37. Now, I have to start K on day 38 to finish the project in 40 days. If I want to start K on day 38, all its predecessors should have finished at least one day before. Then only you can start with K on day 30. That's why The early finish of I, J, and K are 37. Type in the chat box. What will be the early finish of activity I? Sorry, late start of activity I. Late start of I is 37 minus 17. We have, we have a formula as we discussed. Late start is late finish minus duration, 37 minus 1 plus 1, which is 21. What about the late finish of J? 37 minus 5 plus 1, 33. So now you know the answer, so we'll go directly with the answer. So moving back to the network, for activity I, we have two predecessors, D and E. So the late finish will be day 20. For F and G, only one successor, J, starting on 33. So late finish will be 32. Using the same formula, late start is equal to late finish minus duration plus 1. We are calculating the late start of all the activities. Then moving backward, D is starting on 14, late start. So late finish of A is 13. Now, if you go to activity B, we have two successes. E is starting on day 12, F is starting on 28. Type in the, now if you look into the formula, it says previous day of the lowest date value. Lowest date value is 12, previous day is 11. So what is the difference between early start, early finish and late start, late finish? In early start, early finish, we took the highest and the next day. In late start, late finish, we are taking the lowest and the previous day. So now type in the chat box, what will be the late finish of activity C? The late finish of activity C will be, so the lowest is 19, the previous day is 18. And this is the same formula, late finish minus duration plus 1, we are calculating the late start of the activities, right? So now we know the early start and early finish as well as late start and late finish of all the activities. As early as possible, we can start A on day 1, 3, 4, 10, 21, 37, 38, 40. In case you can't start A on 1, at the worst case, as late as possible, even you start A on day 11, 11, 13, 14, 20, 21, 37, 38, 40, still you will finish this project on time. That is the flexibility you are knowing. Okay? 8:31 and late start and late finish are as late as possible when you can start and finish the activity, finish an activity. Now, as I told you, like you can start A as early as possible on day 1 and follow the early start and early finish dates. You will finish this project in 40 days. Even as late as possible, you start A on day 11. Still, even you follow the late start and late finish dates, you can finish this project in 40 days. So now there is a flexibility, right? We need to understand or calculate what is the flexibility in the activity. For that, we are going to calculate the total float of the activities. Total float is how long you can delay an activity without delaying the completion date of the project. How long you can delay an activity without delaying the completion date of the project. So for that, we have two formulas, late start minus early start or late finish minus early finish. So this is early start, early finish. This is late start, late finish. So the formula to calculate total float is late start minus early start or late finish minus early finish. Never take this way, you will get a wrong answer. It's 11 minus 1 or 13 minus 3, not 3 minus 1. So 11 minus 1 or 13 minus 3 is 10. So what is the meaning of that 10? You can delay activity A up to 10 days without delaying the completion date of the project. From where this 10 days is calculated? From the early start of that activity. So from day 1 up to 10 days, you can delay activity A till there will be no delay in the completion date. So the total float is 10 days. Type in the chat box. What will be the total float of activity B? In the same way, what will be the total float of activity B? Is it 0 or 11 minus 1, 10? So total float of activity B is 1 minus 1 or 11 minus 11, 0. It's not 10, it is 0. Okay, one more question, then I'll show the answer for all the, or total float for all the activities. What will be the total float for activity C? You understood the concept? It's just applying the formula. So 9 and 9, what about this? So it will be 10 minus 1 or 18 minus 9, 9. All of you are writing the correct answer. So I'll show you the total float for all the activities, right? So what is the duration of this project? 40 days. What is the total float of activity F? Sorry, activity G? 18 days. Up to 40% of the project duration, you can keep activity G idle. It will not affect the completion date of the project. So out of 40 days, 18 days you can keep activity G idle. 16 days you can keep activity F idle. These are valuable information for the project manager, right? But what is more important is some of the activities are having zero float. For example, activity B. If you delay this activity by 1 day, your project will also delay by a day. So these activities are known as critical activities of a project, and the path formed by these activities will be the critical path of the project. This is another way to calculate critical path. At the beginning we discussed the longest path and shortest duration. Now we are adding one more definition, the least float path or zero float path. Type in the chat box, based on the float information, which path will be the critical path of this project? B, E, I, K, B, E, I, K, that is the right answer, right? So as I told you, that activities bar will be shown in red color. So that's another definition, the least float. So as you can see here, longest route, shortest time to complete, and least float, normally zero float. So now you understood how to calculate the critical path. What is the importance of critical path? Now there are a few more concepts you have to know for the exam. I'll put it as simple questions so you can answer. Even if it is wrong, don't worry, provide your answer. Is it possible to have more than one critical path for a project? Type A if you think yes, it is possible. B, no, it will be always only one critical path. What do you think? Is it possible to have more than one critical path for a project? A, yes, B, no. Don't worry, is it right answer or wrong answer? So A, okay. B, the right answer is yes. It is possible to have more than one critical path. In case total float of C and H are 0, you'll have two critical paths, B, I, K and C, H, K. Right? Question. Having multiple critical paths is an advantage or disadvantage? Type A if you think it will be an advantage. Type B, it will be a disadvantage. What do you think? Having multiple critical paths, is it an advantage or disadvantage for the project? The right answer is disadvantage. Why? The objective of the project manager in a project from schedule management perspective is to finish the project on time. If you have multiple critical paths, any of the critical paths activities are delayed to delay the project. So it's, in fact, if your project is having multiple critical paths, there is a high risk for delays in that project. So if I have only one critical path, my focus will be on BEIK, but multiple means difficult. So it's a disadvantage. Next question. Will the critical path change during the project? Type A if you think yes, it can change, or B, no, it will remain the same. In this case, BEIK, it's not going to change, it will be always the same. What do you think? A. And the right answer is also A, it can change. For example, any of the non-critical path activities are delayed for more than its total float. For example, total float of activity A is 10, you are delaying for 9 days. Total float of A becomes 1. It's not only for activity A, it will be for D, it's a path float actually. I and K not yet affected. Assume you delayed activity A for one more day. total float becomes 0, D also becomes 0. So now we have two critical paths, ADIK, BEIK. Assume you delayed activity A or D for one more day. So this will become -1, -1, -1, -1. So now B and E won't be in the critical path. ADIK will be the critical path. So critical path is changing. So what does that mean? You cannot keep delaying the non-critical path activities forever. Any activity, any non-critical activity, you can delay it up to its total float. So maximum 10 days we can delay, but if you delay for more than 10 days, then that path becomes the critical path. So usually changes in critical paths are due to delays in the schedule or schedule delays, right? So that's basically the key points you have to know for the examination regarding critical path method. So we discussed what is critical path, we discussed some key points, and sometimes the total float will be negative. Negative means there's a delay, right? Then accordingly you will manage the delays, right? So these are the acronyms we discussed: early start, early finish, late start, late finish, critical path definition. So it's clear. Float is idle time actually. You have three types of float: total float, free float, and project float. We just discussed total float. Total float is how long you can delay an activity without delaying the completion date of the project. For example, activity A, total float is 10 days. You can delay it up to 10 days from its early start. There will be no delay in the overall project. Now, what is free float? It's not that important. We'll quickly discuss about that. Free float means float between two consecutive activities. Free float is always calculated between early start and early finish. Let's say activity A, 10 days total float. You can delay A up to 10 days. There will be no impact in the project duration. But the early finish of activity A is day 3 evening. Early start of activity D is day 4 morning. Day 3 evening you are finishing with A, and day 4 morning you are starting with D. What is the free time between A and D? None. So free float is 0, meaning if you delay activity A by 1 day, that may not delay the project, but it will delay the next activity. So free float is 0, right? Free float is the float between two consecutive activities. If you take the next two activities, D and I, D early finish is day 10. I early start is 21. So from day 11 to day 20, from day 11 to day 20, you can delay activity D. None of the other activity will get delayed. So the free float of a D is also 10 days. If you understood the concept, question: what is the total float of activity G? 18 days. Type in the chat box, what will be the free float of activity G? How many free days you are having for activity G? Free float of G. Type in the chat box. So, free float of G is how many days? 18 days. Now, 18 days is total float. I'm asking free float, free time, the float between two consecutive activities. So, for G, successor is J. For G, successor is J. So, what is the free float? You have to look into, okay, 2 days. Anybody else with a different answer or same answer? 1 day. Okay, let's see. What is the free float? 0 days. You have to take early start, early finish, not late start, late finish. Okay, G is finishing on day 14 and J is starting on day 17. In between, we have day 15 and day 16. Day 17 morning, you have to start with J. So free float is 2 days. Again, there will not be questions in the exam to calculate free float. Now you understood the concept. free days between two activities. The next one is project float. What is project float? I did a detailed scheduling and I came to know this project can be finished in 40 days. But however, at the beginning of the project, when they assigned me as a project manager, I agreed with the top management or with the client, I will finish this project, let's say, in 50 days. Or it was imposed on me. We are assigning you as a project manager. Please finish the project in 50 days. Question: in which document you will have this information? The pre-imposed duration or initially assigned duration of the project will be in which document? Name of the document. So I said, at the beginning of the project, of this project, it was told to finish this project in 50 days. In which document you will have this? Very good. That will be, no, not schedule management plan, project chart. Right answer is project chart. High level duration, overall duration of the project is in project chart. Now at the beginning of the project, we agreed we can finish this in 50 days and that is the duration mentioned in the project chart. Now when I'm doing the calculation, I'm seeing I can finish this project in 40 days. So this difference, the difference between the pre-imposed agreed end date and your calculated end date of duration is the project float, meaning the whole project, my calculation shows I can comfortably finish this project in 40 days. But in the project charter, we agreed to finish this project in 50 days. That means day 41 to day 50, even you delay the critical path, there is no impact because you have the project float. The whole project can be delayed for 10 days. But this usually happens only in dreams. It will be other way around. They told you to finish the project in 30 days, and if you are lucky, your calculation will say, I can finish in 40 days. So, there can be three types of project float. One, positive project float, meaning you agreed to finish in 50, calculated to finish in 40, that means you are having positive project float. Or zero project float. You agreed to finish in 40, calculated also 40, this is zero project float or negative project float. These numbers I'm giving indicative, just to, the concept is here, positive, zero, negative. So we agreed to finish in 30, but the calculation shows 40, here I have negative project float. Positive project float is excellent, if you are lucky you will get that. Zero project float is okay, but negative project float is not acceptable. Negative project float is not acceptable. So you agreed to finish the project in 50 or whatever in this example, or 30, but now you are developing a schedule for 40 and you are going to send it for approval. Will it be approved? No. So if there is a negative project float, you have to compress your schedule. So the next technique is about schedule compression techniques. So the objective of compressing the schedule is to match with the agreed or pre-imposed end date, approved end date basically. Sorry, approved duration, end date or duration. So we have two techniques for compressing the schedule. First one is fast tracking, second one is crashing. What is fast tracking? Originally, I planned to do these three activities in sequence. Now what I'm going to do, I'm going to apply some lead between the activities and I'm going to overlap the activities. So between these two activities, I applied a lead and I'll be finishing the project here. That much of time I can say this is fast tracking. So I told you about lead at the beginning of this class. One of the places where lead is applied is, in fast tracking. So here I have applied a lead, here I have applied a lead. Finish to start with a lead. That is fast tracking. Next, crashing. So what we are doing in fast tracking, assume this is 10 days, this is 10 days, this is 10 days. After fast tracking also, duration of the activities are 10 days because we are applying lead and overlapping, this much of time we are saving. This much of time we are saving. In crashing, I have 3 activities again, 10, 10, 10. We are going to do something on the activities and we are reducing the duration of the activities. For example, instead of 10 days, we will do the first activity in 8 days, second activity in 7 days, third activity in 9 days. So instead of finishing in 30 days, right? 9 plus 9, 18, 18 plus 6, 24 days. I can save 6 days, whatever, for example. This is crashing. So fast tracking is overlapping the activities. Crashing is reducing the duration of the activity. How can I reduce the duration of the activities? I can add more resources. I can ask my team to work overtime. I can replace the existing resources with highly productive resources, and by which I can reduce the duration. Next, what is the primary impact of crashing in a project? Primary impact of fast tracking in a project, it increases the risk in the project because you are doing in parallel. Sometimes what you finished here, while you are working on this part, you may want to go back and change or update it. Again, that's a calculated risk you are taking. That is a calculated risk you are taking. So I repeat, fast tracking is doing the activities in parallel, which was originally planned to do it in sequence, by applying lead. It increases the risk of the project. Whereas a crashed project will be high cost because you are adding resources, modifying resourcing that can increase the cost of the project. So that's all what you have to know for the exam regarding schedule compression technique. So as I told you, normally A, B and C are done by one resource and each activity for 5 days. But in fast tracking, as you can see, we are not changing the resource, but only we are overlapping, by which we are saving time. Whereas in crashing, we are adding additional resources, by which we are reducing the duration. The primary impact of fast tracking is it increases the risk. Primary impact of crashing is that increases the cost. Again, there are a few more points you have to know. Just keep this in mind. That might help you to answer questions in the examination. Assume this is only for crashing. Activity A, to crash one day, assume this is activity A, activity B, and activity C. Activity A, to crash one day, it will cost you 10,000 reals. Activity B, to crash one day, it will cost 4,000 reals. Activity C, to crash one day, it will cost, like for example, 2,000 reals. Okay, assume this is A, this is B, this is C. Question is, which activity will crash first? So to save a day in activity A, you have to spend 10,000. Same thing for B, you have to spend 4,000. For C, you have to spend 2,000 to save a day, to crash and reduce one day in the duration of the project. The answer is C. For which activity C, for which activity the cost is less, you will go with that. Not only cost, there will be other factors, but one of the factors you consider is cost. Right. So high risk and high cost, already we discussed about that. This slide you can skip. I'll quickly go through that. As I think Jigad mentioned earlier, can I use 0? Yes, you can. But formulas will be different, little bit different. +1 and -1 will go and so on. Critical path can change over the life of the project, we discussed. Critical path activities can have negative or positive float, but usually will have 0 float. We already discussed. It can have negative float as well. It is possible to have more than one critical path, we discussed. There are several paths with negative float. The critical path is the one that is most negative, if there are several paths. So in case you have negative float paths, then which path is more negative? That will be the critical path of the project. Okay, the output from this particular process is the project schedule, right? So you know the schedule. It will have start date, end date, there will be a sequence, there will be duration, there will be milestones, and the schedule is used to track the performance or progress when you are doing this executing this project. You can present the schedule in 4 formats. Roadmap we already have seen that in 4 formats. Roadmap we already have seen that in Agile, that is for Agile, whereas Gantt chart, milestone chart, project schedule network diagram are for, or the schedule presentation formats. Primavera or Microsoft Project can show the schedule in any of these formats. Just a second. Sorry, I was in mute. I didn't notice that. Okay, what I was saying is, these are the formats in which you can have the schedule: Gantt chart, milestone chart, project schedule network diagram. Primavera or Microsoft Project will be able to show the schedule in any of this format. Do you remember the name of the tool that we used for sequencing activities in a project plan? Type in the chat box. We discussed at the beginning of this class, the only tool by which you will be sequencing the activities is, what is the name of the tool? The tool by which you are sequencing the activities is called, no, roadmap is for Agile, right? High level. That's not even activities, high level actually. Activity sequencing. MSP is a tool, software. Oh, okay. This is a technique. In fact, we call about the tool, it's a technique. Here it's about technique, not the software tech tool. The technique what we are using. No, critical path method is for scheduling. This is for sequencing. CPM, critical path method, is used for, very good. The right answer is precedence diagramming method, PDM. The output is project schedule network diagram. So PDM is a technique for sequencing. Critical path method, CPM, is a technique for scheduling. Okay, right. This is a Gantt chart format. This is a milestone chart format. This is another milestone chart format. And this is a network diagram with dates. Let's go back to Gantt chart. What you are seeing in a Gantt chart, I mean, it depends on the project. In fact, this is an example. So most of the points you want to know is here, right? So one part will have the table, other part will have the graphical presentation. Henry Gantt is the one who proposed this format. So it is known as Gantt chart. So it is known as Gantt chart, right? So what you are having here, the length of the bar is the duration of the activity. And where it starts is a start date, and where it ends is the end date. Length is the duration. This is the duration for subtask 1.2, starting here and ending here. That's a timeline. At least there will be 2 bars for an activity. At least there will be 2 bars for an activity. One will be planned bar, another will be actual bar. One will be planned bar. So here we see planned bar, here is actual bar. So you are able to understand the progress without any explanation. You can easily interpret. You plan to start the activity here and finish here. You started the activity as per the plan, but there is a delay in completion. So the next activity which was planned to start here is now only starting at this point. And there's a delay in this. Is how milestones are shown in a schedule. And here also you can see. So 2 points you have to know about a particular format. That's an examination point. First, what is the advantage of showing the schedule in that format? And 2, when you will use it. The advantage of showing the schedule in a Gantt chart format is you can make the comparison between the plan and the actual very easily, like what you're seeing here. When you will use it in the progress review meeting, in a performance review meeting, if you present your schedule as a Gantt chart, by having a look, all the parties can understand how the project is going on. Is this project ahead of schedule or behind schedule? Type in the chat box. Having a look into that Gantt chart for that particular part of the project, what you're understanding? A, this project is on schedule, happening as per the plan. B, this project is behind schedule. C, this project is ahead of schedule. What are you understanding from that, Gantt chart? So first answer is behind schedule. Anybody else with a different answer? So the right answer is also, behind schedule. Right answer is also. So you can see the plan is here, but the actual is here. So it is behind actual, or even forecast is also showing there's a delay. Second format is milestone chart format. The CEO of your organization is asking you to present the project performance in 30 minutes or 15 minutes. Don't take a printout of the schedule, which can be 50 plus pages easily in a large scale project, and go and show here is a schedule and we're going to explain activity by activity. No, first of all, CEO is not interested in knowing those minute details. And two, they don't have that much of time to spend with you. So here, the reporting will be always in a high level, summary level. That's where you will go for milestone chart. Okay, summary level view of the project milestones. So what are the key milestones? By having a look, you can understand this milestone is planned here, this is actual, there's a delay. Here not it started, here completed, etc. Okay, where you will use it? As I told you, when the upper management is asking for a summary level view of the project details, project schedule, you will go with a Gantt chart. Sorry, you will go with a milestone chart. Okay, this is another milestone chart. Third one is schedule network diagram with dates. This is one we are discussing from the beginning. Last class and this class also we discussed. So this is same like the example what we discussed, but they have start date and end date with the activities. So what is the benefit of showing the schedule in this format? Project schedule network diagram format. You can show the precedence relationship clearly. What is precedence relationship? Logical relationship between the activities. When you will use it, you want to give a look ahead schedule for next 2 weeks, next 2 months, what we are doing, what we are going to do. It is better you give it in a network diagram format. So the relationship between the activities will be clearly understood by the team and they work collaboratively. So your software can show the schedule in 3 formats, like Gantt chart to compare actual versus plan, you will use in progress meetings. Milestone chart to show summary view, you will use in upper management meetings. Whereas project schedule diagram is actually, showing the precedence relationship clearly. It is used like where you will be using it. For the execution team, they want to get a look ahead. Next 2 weeks, what we're going to do. Next 2 months, what are you going to do? You can show this particular format as I told you. Right? Another important point you have to know is when you are developing the schedule using critical path method, you will not apply the resources. Without applying the resources, only with the duration and the other logical relationships, you will be calculating that you will develop a schedule. After developing the schedule using critical path method, you will apply the existing or the available resources and you will check, is this project doable in your resource constraints, right? If yes, that's fine. If not, you have to optimize. Most of the time, there will be, challenges in resource management. So the point to know for the exam, when you create a schedule using critical path method, you won't consider the resources. If you don't develop a schedule considering resources, it won't be realistic. Instead, it will be theoretical, or this will be, theoretical schedule. When you apply the resource and make it as a doable schedule, that becomes a realistic schedule. Okay, so critical path method creates a schedule without considering resources. After that, you will apply the resources and you will check whether it is doable. If not, you will optimize using smoothing or leveling or both. Okay, let's talk about smoothing first. So I have, for example, 10 engineers to work with me in that project, or whatever role you want to take, you can take that. So these are the activities, let's say A, B, C, D, E. So here, when I'm assigning the resources, I will not assign more than the availability. I'll say I will need all 10 for A. I need 8 here, 6 here, 5 here, 10 here. That's how I'm assigning this 10 engineers. At any point in time, when I assign the resources for the activities, I don't provide, or I don't add, or I don't assign more than the available resources. But when you're developing the schedule using critical path method, you are not considering the resources. In a real-time project, it can be thousands of activities. So you're not considering resources, and you are seeing, oh, this is how I can do it A, then I can do B, then I can do C, then I'll go for, D, then E. That's how I'm having a schedule. Now we'll apply the resource and you'll see, is it doable? Okay, so let's say this is A 10 days, B 8 days, C 6 days, D 5 days, E 10 days. When a day on A and D are happening, there are no issues. You have 10 resources, you're utilizing them. But on a day when B and C are happening, you need 14 resources. Availability is only 10 resources. This is called resource over allocation. This is called resource over allocation. But on another day, when D is happening, you're utilizing only 5 resources and other 5 are idle. This is under allocation. Over allocation and under allocation are inefficient. So it has to be perfect. How can I manage? This is what I have to optimize. We already discussed there is no resource maximization, there is optimization. Option 1 is to look into the total float. Option 1, how you can manage the over allocation and under allocation. So option 1, you can work with the float. Can I move C or D or here and there within the float without affecting any of the constraints timeline? Can I do that? If the answer is yes, okay, I can put C in parallel of D, C plus D, together I need 11, which is much more manageable. I can handle that. So work with the float. Or 2, ask for additional resources. You present this to your management. You know what? If I want to finish activity, this project on time, B and C should be finished at the same time. So, we need additional resources. If they give, that's fine. They say, oh, fine. One of the other resources, other project you're going to complete soon, we can provide resources. Or they may say, no, you have to manage the project with the given resources. We cannot provide additional resource. Then you may not be able to do that as well. So third option is delay, right? So I tried my float, not working. I asked for additional time, not working. So what I'll do C after B, and then this is not a major problem. We can bring more resources, more activities, and make those resources busy. So this is the realistic schedule. You have made a doable schedule by optimizing resources. If you are using the first 2 techniques, you are in resource smoothing. If it is the third one, it is resource leveling. So that is about resource smoothing and resource leveling, right? Both techniques are used as resource optimization techniques. Okay, that's what we have seen here, optimization, to ensure it's a doable schedule. Here is an example. In fact, A and B are happening on day 1. Tom and Sue are working on activity A full time. Sue is also assigned on activity B. So on a day when activity A and B are happening, same resource is going to work on 2? No. So that's what we have to manage. Find someone else who is having the same skill set of Sue or Tom, then work will happen. Or, here what's happening, that's not possible. So we are moving B after A, then C, that is resource leveling. Question, resource smoothing may change the critical path of the project. Type A, if you think yes, that's true. Type B, if you think no, it will not change. Resource leveling may change the critical path of the project. What do you think? The answer is no. Resource leveling is working within the float and getting more resources. Next question. Resource smoothing may change the critical path of the project. Resource smoothing may change the critical path. A, true. B, false. Resource leveling. Resource leveling may change the critical path of the project. Yes or no? Here, the answer is yes. In resource leveling, we are adjusting the schedule. We are moving the dates so it can change the critical path as well. That's about. So here you are seeing how it is overall architecture. So the key output of this particular process is schedule baseline. Okay. So like scope baseline, schedule baseline is an approved schedule for the project that will be the basis for evaluating the schedule performance. So what I'll do, I'll play a short video. This is a summary of what we discussed so far. After watching the video, we will discuss the details. Please watch and come back. Let's discuss.
Welcome to the Project Management Institute's Spotlight series. In this presentation, the spotlight is focused on working with the critical path. You're managing a project that has a firm deadline for completion. Emily, one of your team members, reports that a project task she has been assigned will actually take 2 weeks to complete, rather than the 1 week estimated in the project plan. Does this mean you're in danger of not meeting the project deadline? The answer depends on whether or not Emily's task lies on the project's critical path. Monitoring and controlling a project's critical path is essential for successful project management. In this project, there are 3 paths. You can determine the critical path by adding up the individual durations of the tasks in each path. The chain of tasks with the longest duration is called the critical path. The total duration of the tasks on the first path is 18 days. The total for the second path is 24 days. The total for the third path is 12 days. Since the second path has the longest duration, it is the critical path. The critical path is critical because it determines the planned duration of the project. In this case, the project is supposed to take 24 days. The difference between the project's duration and a path's duration is called the float or slack. So the first path has a float of 6 days, and the third path has a float of 12 days. The second path, the critical path, has a float of 0 days. If a task on the first path or third path takes a couple of days longer than planned, it won't affect the project finish date. But if a task on the critical path takes longer than planned, the project may not finish on schedule. That's why you should pay special attention to the tasks on the critical path. If you know in advance that a task on the critical path is likely to take longer than planned, you can take corrective action. For example, you might assign more people to the task to make sure it is completed on time. If it's too late to fix a slipping task, you still might be able to finish the project on time if you complete later tasks in a shorter amount of time than planned. And that's how to identify the tasks that are key to ensuring your project is completed on schedule. Thanks.
Right. So that's a summary of what we discussed, the critical path method. In fact, crashing and fast tracking are not only used only in the planning stage. Later in the project, as you have seen in the video, in case there is a delay and you want to pull it back to the original duration, you will crash and fast track. So, okay, slack. Slack is another name for, float. Yeah, that's a good catch. Float is also known as slack. In Primavera, they mention as float. In Microsoft project, they mention about slack. Concept is same. So total slack, free slack, project slack, or total float, free float, project float. It's nothing different. It's another terminology, in fact. Okay. So this is how Microsoft project schedule will look like. As you can see, this is the WBS level work package. Then you have activities. So likewise, you have various. So this is level 2 work package. activities. So this is how a MS project, you don't want to know this for the exam, just for information. So here the WBS levels are shown as bold. Here WBS levels are shown as bands. So this is level 1, level 2 activities. Then level 3 activities. So that is about, and critical path will be shown in red color. So just a minute. You have to answer this question, but let me just remove the answers. So, and with that, we are done with predictive scheduling. We are done with predictive scheduling. So, as you can see here, we have a question. I'll copy the link and paste in the chat box and take like 1 minute to complete this, or you can scan this QR code and you can, answer the question as well. Okay, either use the link in the chat box or use the QR code to answer this question. Take a minute, less than a minute. Simple question. Okay, so start submitting your answers. Nobody submitted? I'm not able to see a response here. Any problem? Difficult question? Okay, take your time. We got first response. Multiple questions. Oh, really? It's not only one question. 4 questions. Oh, maybe I missed. Okay. Okay, I can see here 4 questions. Okay. Okay, take your time. Maybe 2-3 minutes, not more than that. Okay, let's start discussing. Those who are doing, please submit now, maybe in next 10-20 seconds. 9. Okay. Okay, so 10 out of 15. 5 more responses we are doing. Anybody not doing it? Right, let's start discussing. Those who are still doing, you can submit. 11, 3 more, 4 more. So, a new product development project has the following characteristics. There are 3 main tasks. Task A must be delivered 4 weeks before task C starts. Task B is finished. Once task B is finished, task C will start. What is the relation between task A and B? So, simple to draw. Task A must be delivered 4 weeks before task C starts. Okay, meaning you have to complete task A before 4 weeks before task C starts. So that is, relationship is finish to start, and there is a waiting time of 4 weeks. After finishing task A, 4 weeks, then C. Once task B is finished, task C will start. Okay, once task B is finished, task C will start. So this is B, this is finish to start. So a new product development project has the following characteristics. There are 3 main tasks. Task A must be delivered 4 weeks before task C starts. Once task B is finished, task C will start. What is the relationship between tasks A and B? Okay. 7 of you mentioned finish to start. 2 of you mentioned 12 responses so far. Okay, finish to finish. 2 of you mentioned start to start. 1 of you mentioned start to finish. So there is no direct relationship mentioned. 3 main tasks. A, 4 weeks. There is a lag of 4 weeks. So before C starts, once B is finished, task C will start. So both activities A and B are having finish to start relationship. Both activities A and B are having finish to start relationship with activity C. So it is not mentioned what is the relation between A and B. How will you find it? Just a minute. Okay. How to find the relationship between A and B? So the duration of the activities are not mentioned. Only the relationships are mentioned. So there is a lag also. So can you take finish to start? After, what is the relation A and B? After finishing A, you have to start with B. After finishing B, you have to start with C. You can consider that, but it's not clearly mentioned. Can you take start to start? Can both start at the same time? For this, you have to understand something called open-end activities. If you see, it is something like this. A, B, and then C. What is open-end activity? An activity without a predecessor or an activity without a successor. That is open-end activity. So this is finish to start with a gap of 4 weeks. This is also finish to start. Once B is finished, task C can start. So what is the relationship between A and B? Because, there is no specific relationship mentioned. What is the predecessor of A? Predecessor of B is not mentioned. You will consider this as a, open-end activity. Like if you remember in our example, we took activity A, activity B, activity C, these three, they are not predecessors for each other, but they are open-end. There is no predecessor. We took the early start of A, B, and C as day one. So that means A and B can start at the same time. A and B can start at the same time. So the answer is start to start. Correct. A and B can start at the same time. When they finish, it's according to the duration. After finishing B, you can start C. After finishing A, wait for 4 weeks and you have to start C. So this is open-end, meaning no predecessors. So both can start at the same time. Great. That is first one. How many of you mentioned start to start? I think 2 of you, right? 13%. Now let's go to the next one. Okay. It's not moving to the next one. A company is planning to utilize, what I'll do, I'll also scan and I will show you from my mobile, or I can explain from my mobile. Just a second. Okay. Taking time. Okay. A company is planning to utilize a new product that leverages innovative technologies and processes. The project manager has verified that the component work packages have been defined and constraints for each component have been identified. Which estimating technique should the project manager use to obtain a precise cost estimate of the project? The keyword is precise. We have seen from our discussion, comparing to all the techniques, bottom-up estimation will be giving a more precise or accurate cost estimate. So 60% of you answered correctly. Bottom-up is the correct answer. That's a keyword, precise. Question number 3. A project manager is uncertain about the duration of a project for a new product and consults several group of SMEs, subject matter experts. The first group advises that development can be finished in 40 days. Second group identifies some risk that could make the duration up to 60 days. Third group proposes a new development method that can shorten the time to 20 days. What is the estimated development duration of the new product? This is actually 3-point estimate. They're giving 3 timelines. So the easy way to understand is, instead of like reading and what is pessimistic, what is optimistic, what is most likely, you can put the numbers in descending order. So the highest number is 60, next one is 40, next one is 20. So this is pessimistic, this is most likely, this is optimistic. Okay. This is worst case scenario, best case scenario, normal scenario. So the formula expected value is 60 plus 40 plus 20 divided by 3. 120 divided by 3, 40 days. Some of you got 20, 60, 30. I think you haven't considered the formula, right? If you use the formula, it will be 120 by 3, 40 days. It's 3-point estimate. Or even you can read the question and understand. So it says, some risk that could make up the duration 60 days, that is pessimistic. And they say the first group advises development can be finished in 40 days, most likely. Another one is 20, that is optimistic. Okay, this is a kind of a direct question. If you know the concept, you can answer. The last question is here. A project manager is managing a long-term project that is behind schedule. The client is concerned that the project will be delayed. Which two actions should the project manager take to address the client's concerns? So you have to choose two answers. The project manager is managing a long-term project which is behind schedule. Client is concerned the project will be delayed. That means what you have to do, compress the schedule. What are the techniques for compression? You can crash or you can fast track. Create a new schedule baseline, not yet. Review the change control. There is no enough information to take that decision. Add more resources to critical path task. So yes, adding more resources will reduce the duration. So that is crashing. That is the right answer. Perform a risk reserve analysis. There is nothing mentioned about reserve. Run some activities concurrently, which is fast tracking. So option C is crashing and option E is fast tracking. So C and E are the correct answers. That's it. So now question about crashing and fast tracking. What is crashing? Crashing means adding more resources and reducing the duration of the activities so we can reduce the overall duration of the project. What is fast tracking? Doing the activities in parallel so we can, reduce the duration of the project. The question is, crashing and fast tracking should be done only on non-critical activities. A, this is a true statement. B, this is a false statement. What do you think? Crashing and fast tracking should be done only on non-critical activities. So far the answers are, all of you submitted, okay, 15 responses already. Okay, the answer is, it's a false statement. B, all of you are right. Next question. Crashing and fast tracking can be done either on critical or on non-critical activities. True or false? Crashing and fast tracking can be done either on critical or on non-critical. A, true, B, false. What do you think? Okay, false, true, false, true. Okay, 50-50. Again, this is a false statement. Next question. Crashing and fast tracking should be done only on critical activities. Is it true or false? A, true, B, false. Crashing and fast tracking should be done only on critical activities is a true statement. What is the objective of crashing and fast tracking? The objective of crashing and fast tracking is to reduce the overall duration of the project, right? Overall duration of the project is calculated by the critical path, right? By the critical path. Just a minute. Okay. Here is a critical path. Now assume I'm going to put F and J in parallel. Fast track. Is it going to reduce the overall duration? No. There will be no impact. It's a waste of time and money. If I crash activity I or activity E or B or K, or I put some of those activities in parallel, that will reduce the overall duration. So crashing and fast tracking a non-critical activity is waste of time and money. Next question. Crashing and fast tracking may change the critical path of the project. A, yes, B, no. Crashing and fast tracking may change the critical path of the project. A, yes, B, no. The answer is yes, it may change. For example, when you compress AEIK, sometimes CHK may become the critical path. If you haven't achieved the target yet, you will go and compress the new critical path, right? So the question or the point, you should always compress critical path of the project. Don't go and compress the non-critical path activities. It will be waste of time and money. With that, we are done with predictive scheduling. And next part, we're going to discuss about agile scheduling. So today